We have here a demonstration of self-assembly or spontaneous assembly of large-scale objects. What we are going to use to assemble on the surface of this saltwater solution are some airsoft beads. These are made out of acrylonitrile butadiene styrene, so ABS plastic. They normally sink in water, but I want them to float on the solution, so we're using 20% salt water instead of just straight water. And you can see right away when these beads get into the water, they start to aggregate together. And this is consistent with this relationship here, where the change in Gibbs free energy, delta G, is equal to the change in enthalpy, delta H, minus temperature, times the change in entropy, delta S. In this situation where the beads are aggregating, we have them starting to organize, and so there's a decrease in entropy, so the sign of delta S is negative, and T is always going to be positive, and the change in enthalpy is a little more subtle in this macroscopic model, but what we have are attractions of the beads to each other as they interact with the water. The meniscus that forms between these beads sort of draws these beads together. And we can think of this as sort of analogous to bond formation, and bond formation releases energy, and so this would be would have a negative delta H. Now, if we have a negative delta H and a negative delta S and a positive temperature, whether delta G, change in Gibbs free energy, is negative or positive depends upon the magnitude of the temperature. This is a model of a low temperature situation. You notice the beads aren't really moving around very much, and you can see that the beads aggregate. And so at low temperatures, delta G will be negative and the assembly process is spontaneous. Now, how can I model a high temperature situation? I can simply shake up the container. If I shake up the container, you can see that the beads don't really aggregate with each other. And so the assembly process in this case is non-spontaneous, and this would be a high temperature situation, and delta G, the sign for delta G, would be positive. Now if I let this settle down again, you can see that when we go to the analogy for low temperatures, you can see the assembly does occur. And so this works for these large scale assemblies, and it also works for crystallization at the molecular level. Now, what I have here is some degree of organization in some sort of structure, but this is not the most stable structure that can be achieved, so we can think of this as sort of a metastable situation. What I can do is I can add a little bit of energy and by jiggling on things a little bit, and you can see that the structure begins to organize even further. You have to be really careful here. But if I jiggle this a little bit, you can see that aggregation does occur, and the beads, sometimes tapping it like this. There we go. Okay, we have two crystalline structures here. If I continue to do this, I might be able to get just one. But again, sometimes we get metastable structures. Okay, I submit that that's more organized than the other structures. Okay, we can take this still further. What we can do is we can maybe add a little bit of ethyl acetate to this. Ethyl acetate will not dissolve in the water, rather it'll float on top of the water, and it will start to dissolve the ABS beads a little bit and get them to stick to each other, a process called solvent welding. And if you let that ethyl acetate evaporate, then you can take that welded structure out. And here's a structure that I made last night here, and you can see that it's all assembled together and then welded together. And so people are taking these ideas and they've explored Well, can we take small objects, get them to assemble together using this relation, and then hold the structure together? Maybe we can take very small electronic components and get them to assemble into a circuit. Okay, and so people have explored this idea. Okay, you don't need to use the airsoft beads to show this macroscopic self-assembly. People have used breakfast cereals for this. Breakfast cereals sometimes have very obviously small but also regularly sized, regularly shaped objects that can assemble. What we have also found is that soda straws work really well. Here are 3 soda straws that have been cut into 1/2-inch lengths, and you can see that the soda straws sort of stack side to side and end to end. You notice there's not a whole lot in the way of end to side interactions. This has to do with the way the water meniscus interacts with the ends and the sides of these little cylinders. So again, this involves soda straw pieces that are just sitting in water.